we can move on with next presenter. Next presenter is Semih Sonkor. Hi, Semih. And the title of the presentation is Vulnerability Assessment of Construction Equipment and Examples for an Autonomous Site Monitoring System. So please, Semih, you can share your screen. Okay, I can see your screen.
Okay.
When you're ready, you can start with your presentation.
Okay. Hello, everyone. Thank you, Leonardo. My name is Semih Sonkor, and I'm a research assistant at New York University, Abu Dhabi. And today I will be presenting our paper titled Vulnerability Assessment of Construction Equipment, an example for an autonomous site monitoring system. This paper was written by me, Xinghui, Samuel Prieto, and Professor Borja Garcia Soto. First, I would like to briefly talk about automation and digitalization in construction. So we can categorize it into two groups, and the first one is related to information technology. Under this group, we have building information modeling technologies, generative design using visual programming tools, such as Grasshopper, Dynamo, which can be considered as automation of design, and the use of common data environments to store digital documents in construction. The other group is related to operational technology, and it includes, but not limited to, construction using 3D printers, automation of repetitive construction tasks, such as excavation, drilling, or laying bricks, and automated site monitoring and quality inspection, which can be done by drones or other type of robots. But how is construction different than other sectors, such as manufacturing, energy, or water treatment? First of all, in construction, the environment is much more unstructured, and there's a lack of stability. So the site conditions are continuously changing, which makes it more difficult to keep the environment under control. The second aspect is the collaboration between humans and machines. So even though we are automating some tasks on site, we have still some humans working in collaboration with these machines. And finally, we have multi-stakeholder settings in construction projects, which means we have subcontractors, suppliers, consultants, the client. So there are many different stakeholders, which also makes it more challenging. So the focus of this study is cybersecurity. So I will talk briefly about some cybersecurity concerns in construction sector. First of all, the disclosure of sensitive information. For example, in 2013, hackers gained access to the blueprints of the Australian Intelligence Service headquarters. It shows how important can it be to keep the design, even the design, secure in some specific projects. The second concern is data corruption. For example, in 2012, Shamoon attack on Saudi Arabia's national oil provider resulted in the destruction of content in many workstations. Again, it shows a potential attack can corrupt the data severely. The third aspect or concern is the reputation of damage of the company. The fourth aspect or concern is the disruption of construction operations. For example, in 2020, Bouygues Construction suffered a ransomware attack, and they were forced to shut down their systems worldwide. And last, but in my opinion, the most important concern is the physical damage to the surrounding environment, which includes humans and equipment on site. In 2019, researchers tested 17 brands of wireless controllers of cranes, and they found out that all of them were susceptible to being hacked. So in this study, we are using vulnerability assessment systems to improve the security levels of construction sites. So first of all, we went through some vulnerability assessment systems, and these years are the first release years, but most of them have been updated regularly. And we decided to continue with common vulnerability scoring system, and I will explain why in the following slides. So in this paper, we used an autonomous site monitoring system as an example. And here you can see the diagram of this system. And why we chose this system is we have a prototype of this system in our lab in Abu Dhabi. So that's why we chose this system. And I will go through each level, like there are different levels, and I will go through each level briefly. Level 0 is the robot component level, which includes the robot itself, laser scanner, and some sensors such as LiDARs and RGBD camera. Level 1 is the IT network level, which includes the Wi-Fi network that connects the robot computer to the external computers, and the external computer that collects the data from the robot. Level 2 is ROS network. ROS stands for Robot Operating System, and it is used for giving commands to the motors, giving commands to the sensors, collecting data from the sensors, and so on. Level 3 is the autonomous control level, where we are using it for controlling the sensors autonomously and navigating and localizing the robot using the ROS service. And finally, the last level is the data management level, where we are visualizing point clouds collected from the scanner using a proprietary software, and also visualizing the robot movement, again, using a different software. So as I mentioned earlier, we decided to use common vulnerability scoring system in this study, and I will mention briefly why. It was released by the Forum of Incident Response and Security Teams in 2005 initially, and it has been regularly updated so far. And it's an open framework developed to assess the severities of discovered vulnerabilities. So every day, cybersecurity experts are discovering new vulnerabilities related to different software, and they are mostly using this system to assess how severe it is. It is commonly used by internationally recognized cybersecurity organizations such as NIST, and it is used by the National Vulnerability Database, which is one of the most extensive databases in the available. So it consists of 3 different metrics and group of metrics. The first one is base metric group, the second one is temporal metric group, and the third one is environmental metric group. So the first one is the mandatory metric group to calculate the score. So that's why we used only the first group to keep the study more brief. And these are different metrics and metric values under each metric to calculate the base score using CVSS. So each metric value has a numerical equivalent that can be found in the CVSS document. And there are 3 main categories of metrics. First one is exploitability, which considers how easy to exploit this vulnerability. The second one is scope, which considers if it changes or doesn't change any other component when it is compromised. And the third one is the impact metric group, which considers how much does it impact the confidentiality, integrity, or availability. And this is the formula to use for calculating the base score. So we had 4 different assessors to assess the given system using the given metrics. So for each level, the assessors assigned some metric values for different metrics, and we converted the metric values into their equivalents and numerical equivalents, and we calculated the total base score using these scores. And we wanted to calculate the weighted average using 4 different assessors' scores and using these different weights based on the assessor's knowledge in cybersecurity and their knowledge about the assessed robotic system, which is the autonomous site monitoring system in this study. So at the end, according to our calculation, level 2 and level 3 were the most vulnerable levels compared to the other ones, and level 0 was had the lowest vulnerability. What it shows us is if we are the decision makers on site using this kind of robotic system in construction, we need to pay more attention on level 2 and level 3 while trying to provide a more secure environment. So the conclusions are maintaining robust cybersecurity is harder in construction environments due to the given reasons, previously mentioned reasons. Cyber physical systems such as autonomous earth movers or site monitoring equipment, which was shown in the study, they are particularly open to cyber attacks because they are relatively new in the industry, in the construction industry. And finally, decision makers, if they would like to use some of these cyber physical systems in their sites, they should employ some specific methods, such as the one that we are suggesting, to assess the risks and associated vulnerabilities. And what are the limitations? The number of assessors in the study is limited, which is only 4. The components in the system were not scored individually, but rather than that, we used a level-by-level scoring. And the usefulness of the study was not tested on any other robotic application. So in the future, we are planning to extend this study to include a larger pool of assessors, a component-by-component scoring instead of level-by-level scoring. We are planning to suggest some mitigations for the potential cybersecurity risks. And we are planning to test the usefulness of this study on other robotic systems used in construction. Thank you very much for listening, and I can take any questions if you have.
Okay, great. Thank you, Semih, for your great presentation. Very interesting. And is there any question? No question at the moment in the chat. Any question from the auditorium?
No.
Okay, I have a question in the chat from Jason Zhang. Do you prefer to ask this question directly, or can I read your question?
Yeah, actually, I can read the question. What were the meanings of level 2 and level 3? I can go back to that slide quickly. So level 2 is the ROS level, which is the robot operating system, which is kind of like the brain of the whole system that controls the sensors, that we are giving the commands to the robot, or we are giving commands to collect the data from the robot, or we are, again, we are using to autonomously control, giving the autonomous commands to the robot. And level 3 is the autonomous level, where we are assigning what to do with the robot, if it's going to go to some specific points, and if it will take some scannings in these specific points. We are assigning this in level 3, which is the autonomous control level. But the thing is that level 2 and level 3, they are working together, because level 3 cannot work without the existence of level 2, which is the main, the brain of the system.
Okay, great. Great, Semih. Thank you for your answer. Any other question? No question. No. So I can ask you a curiosity. Do you think that scoring each model one by one, then each level one by one, would provide very different results, or what do you expect from that?
The beginning, I missed the beginning part. Scoring
each module of this system.
Yeah, I see. Each component different.
Yeah, each component.
Actually,
yes.
It might affect the results significantly, because, for example, in level 4, we have visualized point clouds from the scanner, which is done by a software, which is Recap by Autodesk. And the other one is visualize the robot movement, which is done by another software called Arvis. So these two software might have different vulnerabilities, because they are totally different software. So if we can, or if we score them individually, we can actually see which component has the highest vulnerability. Right now, we are kind of generalizing each group, and we are missing like some points. So it needs to be actually done component by component to be more accurate.
Okay, thank you very much for your answer, Semih. And if there is no other question, we can move on and go to the next one.